Splice Original.
Hey, what's up my good people? This is Ekibaru at Flodeco, and today here I'm with engineer
Kevin Odhiambo. Yep.
Tuko hapa tunajenga Precast Maisonnette. Yaani watu wamekuwa kiniuliza, hey, na hii Precast inaweza jenga Maisonnette? So this video is for you today, and we're going to detail how this thing has been put up by the engineer here. Because everything here is Precast. First of all, we are in this place is almost to Matu. Kunaitwaje huko?
Maguguni.
Thika. Almost Matu. I know Matu is not too far from here. And the soils was cotton.
Yeah, black.
So, bwana engineer.
Yep.
The soil depth is 1.6 meters.
Yeah, 1.8
1.8 meters.
That is 6 feet.
Good.
That's the average.
Yeah. So, guys, you already know that Kenya as a country, the bad soils are almost 70%. We don't call them bad soil. They're good soils for farming, but not good for structures. So the issue with cotton soil is normally the up and down movement. Yani inafuranga kama unga ya chapati, ikipata maji, inaenda juu. Now I move sideways. Get it correct. It doesn't go sideways. It's usually up and down movement, kama jeki ya gari. So the up and down movement, if you don't excavate those soils, they'll end up lifting your foundation up and down, and the vigorous up and down brings about cracks, and not only cracks, you get water seepage. Unaingia unapata milango haifunguki, unapata tiles inavunjika. There's so many issues, but we are here with a solution, a technology that I need everybody to adapt, which is called precast concrete, where the engineer will be detailing how he's suspended these precast maisonnette units using the precast pre-stressed T-beam and precast hollow block and or precast panels as a floating foundation, and the walling to partition the house, and it's so easy. So let's go in. Tutembeze. Naona kazi mzuri sana. So can you detail to the audience today mambo ya hii ground beam kunaenda aje hapa sasa? In layman's terms, usitumie majina mazito. Yani audience ni the typical Kenyan who is building, but they need your services, but they need to understand more in a simpler language.
So what we did here,
right,
as nimekwambia, it was 1.8 meters deep, the average foundation here.
Okay.
So na hii nyumba ukiangalia it's over 200 square meters.
Wow.
So excavating hiyo volume yote, kuitoa hiyo black cotton yote,
wow,
and replacing it with now the required hardcore material,
yeah,
would have cost us a lot of money.
Yani hapa tungebeba tipa ngapi hivi hizo matata?
Ukipiga 220 square meter by 1.8.
Right.
Inakuja tipa mingi sana.
Kaso mbili.
Kama 100 plus.
100 plus.
Yeah, so to save the client,
yeah,
na hiyo pesa na time,
okay,
without compromising on the stability of the house, the
yes,
structural integrity,
yeah,
we decided now, and since the walls are precast,
yes,
tuli decide hii nyumba yote itakuwa a framed structure.
Wow.
Itabebwa.
So, let me got this correct. Tuseme tumebeba tipa 100. Najua watu wa tipa mnipendi sana. Ni watu wa bobcat na excavator backhoe ile. But you know what guys, technology is disruptive. Mtapata tu form nyingine ya kufanya kazi. But look, when we talk of about 100 trucks, we talking truck moja hapa jamaa akomboe ile tango wa backhoe excavator inakomboleanga 5,000 shillings by the hour. Itoe yeke kwa lori na lori ende itupe na mahali nenda kutupa kanjo wamengoja walipwe.
Yeah.
So averagely inakujanga around 8 to 10,000 per truck, right?
Actually, the cost that we were given was 10K per truck.
Per truck. So we're looking at about 100 trucks. That is 800,000.
Ile minimum.
Na tujajenga?
Hiyo ni ku-excavate tu. That is just the excavation part only. So now you have to backfill. Okay. Ulete tena sasa approved backfill material.
Okay.
Hiyo pia it comes at a cost. Then you kuilay, lazima uilay in layers, you ramp it in layers. So it was a lot of, it was a very big cost anye client amesave a lot on.
So, my audience, unaweza uzio tiplo, ploti maguta, cheap, 500, unafikiria umeangukia. Ole wako, uende upatane na cotton ya 1.5 meter ama 2 meters. Utatumia 1,800 tena, so eka ile pesa kununua ploti, alafu eka 1,800. No jaanza kujenga, it's very expensive, and we have given you a solution. A solution that we are going to detail very clearly today on these videos on the column and beam foundation, where the column goes to?
Now, so kama hii, now this column is here.
Yes.
Because it is going up. Iko na design yake huko juu. So don't mind it why it's not connected to the house.
Okay.
But now, the base of the column,
yes,
you have to dig it up to the
rock bottom.
Yes. Yani sasa ile
cotton imeishia.
Penye cotton imeisha.
Okay.
And that was the
1.8 meters.
1.8 meters.
Okay.
Yeah. So
wow.
Columns, bases, you have to dig it up to the rock material.
Okay.
Penye solid ground iko.
Wow. And then sasa unaona hii column then una-connect na ile ingine.
Yeah, so now this is a matter of design.
Okay.
So if you look at this span,
yes,
hii column na ile, this is 7 meters.
7 meters?
Kwa
hewa?
Kwa hewa.
Wow.
And there is no intermediary support.
Okay.
So that's why you have to do a tie beam, a ground beam all around it now.
Okay.
Kuzishikanisha pamoja. Juu sasa ni frame.
Okay.
So hiyo beam ndio inabeba sasa now the ground, the T-beam za hii slab. Since it's suspended,
okay,
tulitumia the T-beam technology.
Okay.
Tukafunika
sasa the top. Sasa hapa chini ni shimo.
Yes, hapa ni hole. There's like a space beneath the slab.
Okay.
So there's no contact between the ground, excavated ground at the bottom of the ground floor slab. Okay,
so my audience today, the mid section is hollow, meaning saa zile kamuchanga kako hapo katikati kanataka kwenda juu, kako na allowance ya kucheza. So you leave an allowance, right?
Minimum of 1 foot.
Yeah, 1 feet allowance, which is 300 mm, where the soil can go up and down without interference. But the column section is what goes to the rock bottom, and then the ground beam is floating. And I'm more concerned about the 7 meter span. So the structure engineer has deeper details with computer mathematics on what type of rebar and the size of the beam and the concrete that is already casted. Can you tell us the details of this beam? What is the... Sasa tumia zile majina zenyu tuelewe hapa.
So on basic terms,
yeah,
we came up with, now we have the architectural of the building. So you do a structural drawing and an analysis of the building.
Okay.
And we notice that this wall is not load bearing.
Right.
So it is a frame structure. So these beams, all the beams are designed for accordingly to accommodate for easy T-beams.
Okay.
So if you see this beam is like 7.7 meters, it's a long beam, but now you have to get the nominal area right and the reinforcement right, so that hautakuwa na failure, any shear cracks ama nini in future.
Wow.
So ni a matter of design. Everything else is a matter of design.
Okay. So, good question. Load bearing walls. Na hapa tunaongelea precast panel. 90 mm. Hollow inside. No cement. Just click and lock and then boom. So, the reason why we use mostly masonry walls, darugo stones, they do have an element of the load bearing concept, but the precast panel doesn't have that.
So, for masonry, any mawe, even darugo, above 9 millimeters,
yes,
it is considered as a load bearing wall.
Okay.
But now it is heavier than this panel.
All right.
Yeah. But so, anything below the 9 millimeter is not load bearing.
So 9 millimeter ni ile mawe wanaita ya 9 ama ya 6?
Inakuanga ya 9 hiyo, wanaitanga ya 9 hiyo.
So guys, 9 millimeter, well, wait a minute. The dimension of a blocks are usually 200, 400 by 200.
By 200, 200, 400 and 200.
Yes, so the 200, 400 is what you're calling a load bearing?
Yeah, the load bearing.
So the usually the 151, 400, 200 you see?
Load bearing.
Okay.
That's not load bearing.
Wow.
That's considered as a partitioning wall.
Okay. So, audience, what the engineer is telling us today, if you need to use our precast wall panels, which are not load bearing, you need to build a frame structure. A frame structure is your columns and the beam is a frame, and this is the main house. The precast panels are fitted in as infills, and the foundation is clicked and locked. It's ready to assemble foundation really quick. So let's go around the house as we speak more about this unit. So these are the blocks.
Yeah, for the slab.
All right. Right. And these are the pre-stressed T-beams.
Yep.
So bwana engineer, spans. Tuseme hapa hii lounge. Ulikuwa unaenda span gani?
Kwa hii nyumba, the maximum span that we have is 5.2 meters.
Okay.
5.2 from beam to beam.
All right.
Yeah.
Okay.
Na 5.2,
Yes.
it's
5.2 span. That was the shortest
5.2.
span.
That was the maximum, the largest span.
Okay.
For spanning the T-beams.
Okay.
But now the in situ beams, the longest beam is 7 meters.
7 meters.
Yes.
Na hiyo ilikuwa D what?
D12. It's
D12.
a matter of design. Okay, hii system, the good thing na hii system yako, this thing we can get the dead load.
Okay.
Then we apply the live load.
Okay.
So now when you're designing for the building,
Yes.
hata ukitaka kwenda 10 floors with those big spans, you can just do it.
Wow.
It's a matter of design.
Okay.
Yeah.
So, guys, you can see the precast wall panels, they're already into place. And I'm here with Bwana Engineer. There's a question that I keep asking every day. Wananiuliza aje. Na hii wall, itashikwa namna gani juu? So, we are now at the level of the upper beam. We call them rim beams. Hii ni
the
ground
rim
beam. Hii now ni rim beam.
The first floor beam, yeah.
First floor beam. So, we are easily marrying it. When you're doing our formwork, inaingia ndani.
So when you're doing the formwork, when you're doing the bottom formwork part of the beam,
yes,
these panels will be inside the beam. So the formwork will be below the panels to some level, so that it can interlock.
Like well, how many millimeter you giving it?
100.
So 100.
100 even.
So we are
chuma ya beam iko hapa.
Okay.
So the beam is locking this thing.
Okay.
So hii beam ikikuja, we're casting it now when the panels are in place.
Okay.
So once it comes and
you do the
cures,
in situ thing.
Once it comes and cures,
okay,
it becomes a very solid wall.
Inakuwa kitu moja kama monolithic.
It becomes monolithic now.
Okay.
Yeah, na hapa chini we'll do the floor screeding, then now it locks the thing all together.
Okay. And audience, there's one thing that we forgot to mention to you. The services, plumber, electrical, nyinyi watu, tuko pamoja hivi. So, when you're installing these panels, the moment you raise them up, umezisimamisha, I need the electrician, I need the plumber for the services. Why? Because, remember, I said they are hollow, they have a hollow section. The hollow section does three things. The first unique thing about the wall panel that is hollow, it reduces the sound. We all know sound doesn't travel through the vacuum system. So, you might think my wall is very thin. Hey, na hiyo wall, neighbor wakiongea sitawasikia. No. The hollow section is an acoustic form where the sound, whenever it tries to penetrate, it goes inapotelea huko ndani. That is number one for the hollow section. The hollow section is very important for the services because we just drop down our conduits. Our PPR pipes for the bathrooms, they go through this section. There's no more hacking. Unakumbuka ile mayadarugo tunakutaga tunakatakata. There's no more hacking, so you just drop them down. And before you pour concrete, the pipes need to be protruding
Already,
up.
yeah.
What is the other thing for the hollow section? Watu wako Limuru pale kabaridi kanapiga sana. The hollow section, to some extent, baridi haiwezi kupenetrate. And that's all about the precast wall panel. Ikifika section ya dirisha, tunakatia vizuri. The rest they just click and lock. And the beautiful thing about these precast wall panels, they barely need they barely need plaster. And if they need plaster, it's just how many mm? Just bare minimum.
10 millimeters.
10 mm. 10 mm is just to make them even, and then you skim coat them directly. The skim coat product is sold by most paint distributors. Not all paint distributors. We now have skim coat companies. We prefer using Sahara. Sahara is a brand of skim coat. And what is a skim coat, guys? A skim coat is a product that is made from white cement and has polymer in it. Polymer ndio inaifanya ishikane. Alafu when you mix with water and you apply, inakupatia the smooth white surface that you need before you apply the main paint. All right. So, Bwana Engineer, we need to go inside and see this house.
Sawa.
So, let's go in. So, I can see the windows are big. Wakenya siku hizi wameogopa mwizi. Dirisha kubwa. Kuna dirisha moja hapa kwa entry imenifurahisha sana. So, this dirisha here is, if this beam was 7 meters, this dirisha is 6 meters, right?
Yep. Minus 1.2, you're 6 point, you're 6.
Okay. So, we're right here in at the entry level. It's a humongous house, by the way. This is how many square meter on this
220 square meter.
220 square meter only on
This
the
floor. This
and then
floor.
the upper floor will be another 220.
Yeah, but now this is a double volume. So, but it's around.
Oh, so this is double volume.
Yeah, this is a double volume. So
Oh,
there's no
that's why I
slab
don't see
here.
the ring beams here. But you're going to cast them, okay. So we're going to be documenting this unit as we progress. And how many days have you used so far? Because the other thing, guys, we need to know, what am I saving? Why should I go digital? So the very reason why precast is becoming more recommendable way to build, because of ease of time, less labor. And how long have you been on this site up to this point?
Up to this point,
Yeah,
this is our third week.
that week.
Yes, this is our third week.
Okay, okay,
Yes.
okay. Did you have any stoppage? Was there anything?
Well, I can. It's a very quick process. Using the precast is a very quick process.
Okay.
That is something I can attest to.
Okay,
But due to some site challenges and what,
yeah,
we could have done a maximum of 2 weeks.
2 weeks.
Yeah.
Okay.
Maximum of 2 weeks, so up to this level.
Okay. Okay. So 2 weeks is good.
These things you just install in a day. It's a fast process.
So, guys, as you've heard from our engineer here, building with this product saves you time. And we all know time is money, you know. Time is money.
Sana,
So
sana.
if you have people staying at your site, you need to be paying them every day, because wakikuja kwa site asubuhi, jioni utawaambia hakuna kazi, ama hakuna pesa. So it eliminates a lot of issues. And also the precast wall panels are easy to click and lock, so you can actually zungusha the whole house in what, 2 days?
2 days.
2 days.
Maximum.
While if you have done the masonry walling, kwa maybe an average of 10 days.
7 days.
7 days.
Thereabout.
Yeah. So you save time also on that. And then
Non-skilled labor.
yeah. And then the labor type you're using unskilled laborers here and just a few foodies, right? Wow. So thank you for watching my video. We'll do a continuation of the progress. So next week we are going to lay the ready to assemble slabs. It's going to be very interesting. There will be no props. We're saving our trees. We're not cutting down the trees. We need green construction method. So we are saving the trees here. There will be no more trees. The river also will be minimized. And I'll be taking you through here, everywhere. And thank you for tuning in. My name is Eki Barwe Flodeko. Asanteni sana.
My name is Engineer Kelvin Odhiambo. Asanteni pia.
Life original.